In the world of mission-critical AI, accuracy is non-negotiable. But what happens when the most creative engines become the most structurally unreliable? At Sage, we faced a fatal flaw. Our powerful engine, capable of interpreting ancient geometric patterns, couldn't reliably adhere to a modern, structured report format. This is the intersection of high creative fidelity and low schema adherence, a silent killer in production systems. We call this structural hallucination, the tendency of a probabilistic model to break its own formatting constraints, even when the semantic content is correct. The model might merge two sections, drop a critical header, or translate structural markers into the wrong language. This structural imprecision breaks downstream parsers silently. For a mission-critical system, a clumped or missing section means a user receives a reading that is incomplete or unrenderable. The application fails because the architecture is imprecise. Standard solutions like better prompting reduce the failure rate, but cannot eliminate it. A probabilistic model will always have a non-zero failure chance, and at scale, 90% compliance is a failure. Our solution shifts the engineering focus. We don't try to engineer around the LLM, we engineer after it. We built a deterministic firewall. This deterministic safety layer is the Structural Integrity Enforcement Pipeline, or SIEP. It ensures 100% schema compliance before the output reaches the user. The SIEP operates in 6 distinct, sequential stages, each targeting a specific failure mode common in production LLM outputs. The core insight is that the semantic content is often still present, even when the structural marker is missing. We treat the LLM as an unreliable narrator that needs post-processing correction. Let's explore the 3 core innovations within the SIEP that enable synthetic structural recovery and robust multilingual shielding. The doctrine firewall and header shielding ensure that any malformed, partially translated, or omitted header is replaced with the exact canonical string for the target locale, maintaining doctrinal purity. This is our core innovation. By scanning the prose for semantic anchors, unique, domain-specific keywords, we can synthetically inject the missing header at the correct position, eliminating the need for costly LLM retries. For multilingual output, we implement hyper-isolated translation shielding. Content is wrapped in opaque positional markers and explicitly excluded from translation, preventing the LLM from corrupting the established segment structure. After deploying the SIEP across all supported languages, the impact on our system reliability was immediate and absolute. We achieved 100% schema compliance. Over thousands of generations, we have observed 0 instances of clumped sections or missing headers, fulfilling the exact architecture required. The zero-trust translation shielding eliminated language leaks, and by repairing output in milliseconds, we eliminated LLM retry loops, significantly reducing our latency. Generative AI is powerful, but for it to be useful in high-precision industries, it must be made reliable. The SIEP is our contribution to that mission. We shift the burden of structural integrity from the probabilistic creative model to a deterministic logical pipeline, achieving stability without sacrificing the model's expressive power. For those interested in the academic details and technical implementation, the full white paper and official peer-reviewed framework is available on Zenodo. Dig deeper. Experience the Oracle. The engineering described in this post powers every reading at Sage.